Imagine looking into the sky and seeing the sun disappear at noon. No forecast, no astronomy app, no scientist explaining orbital mechanics. For millions of people across history, that darkness was not an interesting celestial event. It could mean a king was doomed, a god was furious, or disaster was already approaching. And eclipses were only the beginning. Humans once filled oceans with monsters, read political warnings in comets, blamed disease on poisoned air, and explained fossils as evidence of giants. These ideas can sound ridiculous today, but most were not created by foolish people. They were attempts to solve terrifying mysteries with the evidence available at the time. And once you understand how reasonable some of them seemed, modern certainty becomes much less comfortable. Start with the sky, because ancient people watched it obsessively. The heavens were the largest information screen humanity possessed. No notifications appeared there, but changes still felt meaningful. Stars moved predictably. Seasons returned. The moon followed a cycle. So when something broke that rhythm, people noticed immediately. A comet was especially disturbing. It appeared suddenly, grew a strange luminous tail, then vanished. Today we know comets are icy bodies orbiting the sun. Their glowing tails form when solar heating releases gas and dust. But before that explanation existed, a comet looked like an announcement. In many societies, unusual celestial events were connected with earthly events. Chinese court astronomers recorded comets, eclipses, and other phenomena carefully. These observations could carry political significance because rulers were linked to cosmic order. Medieval European writers also sometimes treated comets as warnings of war, death, or instability. The famous Halley's Comet became associated with dramatic historical moments. It appeared in 1066, the year of the Norman conquest of England. The Bayeux Tapestry even shows observers staring upward at what appears to be the comet. Of course, the comet did not cause the invasion, but imagine living through both events without modern astronomy. A strange object burns across the sky. Soon afterward, kingdoms collide. Humans are exceptionally good at connecting dots, especially when the dots are frightening. Eclipses were even more dramatic. The sun did not merely look unusual, it vanished. Different cultures developed very different explanations. In parts of ancient China, eclipses were sometimes associated with a creature consuming the sun. Similar devouring stories appeared elsewhere. In Norse tradition, wolves were described as pursuing the sun and moon. In some South Asian traditions, the figure Rahu became associated with eclipses. The details differed, but the emotional logic was similar. Something that should be permanent was suddenly being attacked. This could lead to rituals intended to restore cosmic order. People might shout, strike objects, pray, or perform ceremonies. From our perspective, banging drums during an eclipse cannot move the moon. From theirs, there was an interesting problem. The ritual happened, and eventually the sun returned. That is exactly how false explanations become durable. If an action is always followed by the desired outcome, humans naturally connect them. Every eclipse ends, so almost any ritual performed during one can appear successful. It is basically the universe giving ancient humanity the most misleading feedback imaginable. Then there were monsters. Look at historical maps, and you may find enormous creatures swimming through unexplored waters. Serpents coil between ships. Giant fish surface beside coastlines. Strange animals occupy blank spaces beyond familiar routes. The phrase, "Here be dragons," is often associated with old maps, although the exact wording was much less common than popular culture suggests. Still, fantastic creatures absolutely did appear in historical cartography. But these drawings did not always mean mapmakers literally believed every ocean contained that exact monster. Some were decorative, others represented danger, uncertainty, travelers' reports, religious imagery, or real animals described badly. That last category matters. Imagine hearing about a walrus without seeing one. Someone tells you it has enormous tusks, a heavy body, whiskers, and lives near freezing seas. Now transmit that description through several people. Then ask an artist who has never seen the animal to draw it. Congratulations, you may have invented a sea demon. The ocean was perfect territory for exaggeration. Sailors encountered whales, giant squid, unfamiliar sharks, massive rays, and animals rarely seen near shore. Storms could destroy ships without explanation. People disappeared beyond the horizon. When information is scarce, uncertainty tends to grow teeth. Even real animals could become mythology through imperfect observation. A whale surfacing at distance might seem serpentine. Groups of animals could appear to be one enormous creature. Floating debris might resemble a living shape. Fear does the rest. And fear had plenty of material to work with. Nature constantly produced events people could witness but not explain. Earthquakes shook cities without visible causes. Volcanoes exploded from mountains. Lightning struck trees from clear-looking skies. Strange lights sometimes appeared overhead. The ground itself occasionally opened. Without geology, meteorology, chemistry, or modern physics, explanation became a creative survival skill. Lightning offers a perfect example. Many cultures connected thunder and lightning with powerful supernatural beings. The Greeks associated lightning with Zeus. Norse mythology connected thunder with Thor. Other societies developed their own divine explanations. This was not simply fantasy replacing science. It was an attempt to identify agency. Humans are built to detect agents. If bushes move, maybe something moved them. That instinct is useful when predators exist. But the same mental system can produce invisible agents when natural forces act unpredictably. Lightning hits a house. Something caused it. If the mechanism is invisible, intention becomes an attractive explanation. Then disease made everything harder. For much of history, microorganisms were completely unknown. People could not see bacteria or viruses. Yet epidemics spread through entire communities. One person became sick, then another, then dozens, sometimes thousands. A common explanation in Europe was miasma, the idea that disease could be caused by harmful or corrupted air. Bad smells became suspicious. Swamps, sewage, decay, and crowded neighborhoods seemed dangerous. And here comes the twist. Miasma theory was wrong about the biological mechanism, but avoiding filthy environments could sometimes reduce exposure to genuine sources of disease. So an incorrect theory occasionally produced useful behavior. That is one reason bad explanations survive. They do not need to be completely useless. They only need to work often enough to feel convincing. Consider malaria. The word itself comes from Italian roots meaning bad air. People associated the disease with marshy environments. They were wrong about the air. Mosquitoes were the actual vector. But marshes really could mean more mosquitoes. The observation contained useful information. The explanation missed the mechanism. That distinction is one of the most important lessons in science. You can observe something correctly and explain it incorrectly. Now move from disease to the human body itself. Before modern anatomy and physiology, physicians often worked with systems inherited from earlier traditions. In Europe, one influential model involved 4 bodily humors: blood, phlegm, yellow bile, and black bile. Health was often described as a balance among them. Illness could be interpreted as imbalance. Treatments sometimes included bloodletting, purging, dietary changes, or other attempts to restore equilibrium. Bloodletting continued for centuries. Today, removing blood unnecessarily can obviously weaken a sick patient, but within the older theory, the treatment made internal sense. If excess blood caused illness, removing blood sounded rational. That is a dangerous feature of coherent theories. A theory can be internally logical and still be wrong. Once people accept the starting assumption, every later step may look perfectly sensible. The mistake hides at the foundation. The natural world created even stranger puzzles underground. For centuries, people found enormous fossilized bones with no living animal nearby to explain them. Imagine uncovering a giant femur before anyone understands extinction. What is your conclusion? Dinosaurs are obvious only after someone discovers dinosaurs. Earlier observers sometimes interpreted unusually large fossil bones as remains of giants, legendary creatures, or animals known through religious or classical stories. Fossils were not immediately understood as evidence of extinct species from unimaginably distant eras. Extinction itself was difficult for many thinkers to accept. The idea that entire species had existed and vanished challenged older assumptions about nature. Fossils forced scientists to confront something deeply uncomfortable. Earth had a history far older and more violent than many people expected. By the late 18th and early 19th centuries, figures such as Georges Cuvier, helped establish extinction as a scientific reality through comparative anatomy. Bones were no longer merely curiosities, they became evidence. And evidence began rearranging humanity's timeline. That transformation happened again with weather. Before modern forecasting, unusual atmospheric events could carry symbolic meaning. Red skies, strange halos around the sun or moon, unusual storms, and other phenomena might be interpreted as omens. Some observations did have genuine predictive value. A halo around the moon can sometimes appear when ice crystals exist in high clouds. Those clouds may precede certain weather systems. Sailors and farmers accumulated practical weather knowledge through generations of observation. But accurate pattern recognition easily mixed with superstition. A storm follows a strange sky once, and people remember it. Nothing happens after the same sky 10 other times, and those cases are forgotten. That bias still exists. We remember the prediction that came true. We forget the 20 that failed. Ancient people were not uniquely vulnerable to this. Modern humans do exactly the same thing with markets, sports, health trends, celebrity predictions, and social media rumors. The technology changed, the brain did not. Perhaps the most fascinating example is astrology. Across different civilizations, humans tracked planets and stars with extraordinary precision. Babylonian astronomers created detailed celestial records. Greek and later Hellenistic traditions developed complex astrological systems. These practices helped preserve observations that also contributed to astronomy. But astronomy and astrology eventually separated because they ask different kinds of questions. Astronomy asks where celestial objects are, how they move, and what physical laws govern them. Astrology claims that celestial arrangements can meaningfully influence or predict individual personalities and earthly events. Modern scientific testing has not established astrology as a reliable predictive system. Yet its historical appeal is easy to understand. The sky is ordered. Human life feels chaotic. Astrology offers a bridge between them. Your suffering becomes part of a pattern. Your personality receives a cosmic explanation. Uncertainty becomes a chart. That emotional function is powerful. And this brings us to the biggest misconception about old beliefs. People in the past were not walking around believing every strange idea equally. Skepticism existed. Debate existed. Scholars challenged one another. Different communities held different explanations. Knowledge changed gradually, not in one cinematic moment when everybody suddenly discovered science. Even eclipses were predicted with increasing accuracy long before modern astrophysics. Ancient astronomers recognized patterns in celestial cycles. Greek thinkers proposed natural explanations for many phenomena. Scholars across the Islamic world preserved, criticized, expanded, and tested astronomical knowledge. Later scientific revolutions built on centuries of accumulated observation. Progress was messy. Wrong ideas and brilliant discoveries often existed side by side. That may be the most educational part of the story. A medieval map can contain imaginary creatures and excellent geographic information. A physician can use a flawed theory while making careful clinical observations. An astronomer can calculate planetary positions accurately while also practicing astrology. Knowledge does not arrive as a complete package. It advances in pieces. And sometimes the strangest historical beliefs were not failures of intelligence, they were failures of available evidence. If you cannot see microbes, invisible poisonous air is plausible. If you cannot identify fossils, giants are plausible. If you cannot calculate an eclipse, cosmic danger is plausible. If sailors describe gigantic unknown animals, sea monsters are plausible. The real danger begins when a plausible explanation becomes protected from correction. Science works differently because explanations must remain vulnerable. A claim should be testable. Evidence should matter. Predictions should fail when the theory is wrong. Better explanations should replace weaker ones. That sounds obvious now. History shows that it is not, because modern people still create explanations faster than they verify them. A video appears online. Someone finds a pattern. A dramatic theory fills the gap. Millions share it before anyone checks the source. The sea monster has simply moved from the edge of the map to the top of your feed. We laugh at people who feared comets, because we know what comets are. Future generations may laugh at some things we confidently believe today. The lesson is not that people in the past were gullible. The lesson is that certainty becomes dangerous when evidence stops being allowed to change it. Every generation inherits a map of reality. Some parts are accurate, some are incomplete. And somewhere near the edge, there are probably still monsters we have drawn, because we do not yet understand what is actually there.